Hey, physics friends. I am sorry that I could not be here today. I wanted to take some time to explain this position versus time quiz that you all took yesterday. I know that you had lots of questions and you're very unsure of stuff. And rest assured, it's going to be okay. A lot of it is just understanding what does the word position, what does the word stopped, when is speed, what is displacement, what is velocity. All these things have very specific physics meanings. And you're not quite sure about them right now, and that's okay. We're going to go through this together, and hopefully by the end of this, it makes a little bit more sense. And I'm going to give you another one. So remember, if you remember back to my intro video when I talked about the beginning of every physics chapter is tough. And the first quiz you get is always nasty. The first time you saw dimensional analysis last chapter, you had no idea what you were doing, and you all came through in fine style. And it's going to be no different this chapter. Take heart, pay attention, ask lots of questions, and we'll get through it together. Let's go. So at this point in time of me filming this video, this was what the results looked like after everybody from second hour had taken their little quiz with a partner. Right now, I can see question number 1, question number 4, question number 10, and question number 12. These are the tricky ones. So we're going to go through all of them, but I can tell right away question number 1 was a big one. So let's talk about this. Which section or sections is the position fully positive? So a big question is 0. First of all, do you remember putting your cups down on the ground? When you're in the pot, maybe some of you paid attention to those cups, maybe you didn't put any cups down, but when is your position positive? Here's your position over here on the y-axis. So basically, anytime your position is in a positive number. So here's where your position's positive. Here's where your position's positive. Position positive here. Position positive here. Now 0. 0 is not positive, nor is 0 negative. It's in between. It's not positive and it's not negative. It is the boundary between positive and negative. So 0 is not positive and 0 is not negative. Somebody asked me that, and I had to tell them, I can't tell you, but 0 is not positive, 0 is not negative. Here is where your position is negative. So where is your position fully positive? In C, it's partially. So the correct answer is D, E, and F. In spots D, E, and F, you're fully positive. G, you're neither positive or negative. C, you're partially. And A and B, you're fully negative. Question number 2. Which section is the object stopped? So that's when is it horizontal? You have a horizontal line at D and at A. So the correct answer, and also G. At A, D, and G. Number 3, at which section or sections is the speed negative? This is a trick question. Speed is always positive. Speed is the absolute value of velocity. For instance, right here, at section B, I go 1 meter in 1 second. So I go 1 meter in 1 second. So my velocity is -1 because I'm traveling -1 meter in 1 second. So my velocity is -1 meters per second. That's my velocity. My speed is 1 meter per second. Speed is always the absolute value of velocity. It can never be negative. Number 4, which section or sections is the displacement negative, meaning you start some way and then you end up more negative than where you started. So A, you're not moving, so there's no displacement in part A. B, that's a negative displacement because you're starting at -1 and you're ending at -2. Your displacement is always your final position, your final distance minus your initial position. So, for instance, in this case, my final is -2. My initial is -1. So -2 minus -1 is -1. So that displacement is negative. In part C is a positive displacement. I'm going in the positive direction. I can show you using this equation as well. My final position is 1. My initial position was -2. So 1 minus -2 equals 3. So my displacement in this case was a positive 3. And you can see that I went a positive 3 meters. Sorry, I'm still getting used to this smartboard. So going through the other places where my displacement is going to be negative, section E and section F. So the correct answer for this one, where is your displacement negative? B, E, and F. Number 5. Which section is the velocity? Which section or sections is the velocity positive? So, part 1, my velocity is 0. Here I've got a negative velocity, and the velocity is just directly related to slope. Up on the board, I have velocity is equal to displacement divided by time. So you can find your displacement here. It's your final position minus your initial position over the time it took. So -2 minus -1 is -1 over 1. So my velocity for part B is -1. It's just the slope. That's how I'm calculating. It's your rise over your run. So the question for number 5, when is the velocity positive, is when does it have a positive slope? Right here at C, E, and F are negative slopes. So the only place where I have a positive velocity is going to be section C. Number 5 is C. And number 6, which section is the speed the fastest? So that's going to say which has the biggest slope. So and it counts for both positive and negative. So let's say you had a slope like this slope right here. I go up 3 over 1. So this has a slope of 3. And that's my speed. My speed is 3. This slope, it goes down a half, and then it goes over 2 seconds. So that's like 0.25. So this has a speed of 0.25. And it's got a velocity of -0.25. So which speed has the biggest? It's the one with the largest slope, which is going to be section C again. So there your answers are. Sorry, I had to kind of erase them as I went through. Let's go on to the second section. The exact same questions, just a different graph. But what makes the second graph a little bit harder is I'm starting to have curved sections. This is also why I had you guys make that challenge graph, and I had a bunch of curved sections so you understand where I'm speeding up and where I'm slowing down. To go from standing still to having a velocity, I'm speeding up at part B. So you have to kind of understand a curve and what that means. So number 7, which section or sections is the position negative? A, B, and C. Because those are all where you're below that line. These are all negative positions. These are all positive positions. Part number 8, which section or section is the object stopped? Where is it a horizontal line? A and F. A and F. That's where the line is horizontal. And this one looks like it's sloped up. If you asked me, I told you, if it looks horizontal, it is horizontal, and that's totally what's going on at A and F. Number 9, which section or sections is the speed negative? There it is again with that trick question. Never. I. In this case, I. Never or nowhere. Number 10, which section is the displacement positive? Where are you going from someplace and you're getting higher up? Your position is becoming more positive. At section A, you're not changing position, so it's not A. In B, you are getting more positive. In C, you're getting more positive. In D, you're going, when I say getting more positive, you're starting at some position, 0, and you're ending at another position, 1. You're definitely getting more positive. At E, you're going from 1 to 1.5, 1.4. F, there's nothing. You're not moving with F. And then G, your position's getting more negative. H, your position's getting more negative. So where is your position getting, where's your displacement positive? B, C, D, E. And remember, the definition of displacement is your final position minus your initial position. So what's my final? What's my initial? Like, for instance, letter C, to just do one example, my final position is 0. My initial position is negative 0.75. So it ends up being a positive displacement. Or you can look at where are you moving up on the graph. Where is your velocity negative? Anywhere you have a negative slope. So first of all, I have no slope at A, so that's not positive, it's not negative. At B, my slope is changing. It starts out at 0, but then it ends up being positive. It's positive over the whole place, except for at the boundary between A and B. So it is positive. The velocity is positive at section B. At section C, it's the same speed everywhere, so that's also positive. At D, it's the same speed everywhere. It's faster than C, but it's positive. And then E, I still have a positive slope everywhere I look. So E is also positive. And at the end, the velocity ends up stopped. I end up stopped. And then at G, I'm speeding up. So I end up with more negative. So these are negative slopes. So I'm going in the negative direction. I have negative velocity here. But it's getting bigger and bigger. So I'm speeding up, moving in the negative direction. At H, it's a constant negative velocity. So where is the velocity negative and what section or sections? G and H. That's where the velocity is negative. In part G, I have a negative velocity and I'm speeding up, but it's negative the entire time. I'm getting faster. And at H, it's a constant negative velocity. And number 12, which section are you speeding up? Meaning I'm going from stopping to moving. So part B, great example of speeding up. I'm stopped here, and I'm moving at part C. So B, I'm speeding up. Letter E, that is slowing down. I'm going from moving, I have a slope, and then I'm stopped here. So when I go from moving to stopped, we call that slowing down. Part G, I'm going from stopped to moving. That's speeding up. G is speeding up. What sections are we speeding up? B and G. And this is where it gets confusing for physics students, because you see the word up and you think, oh, if the graph is going up, that's totally speeding up, because look, the graph is going up. You're speeding up there too, but you're going down. What you really have to look for when you're looking for speeding up is when you go from stop to moving. Slowing is when you go from moving to stop. And when I say stop, I mean like a horizontal line. On my position versus time graph, I have a horizontal line. So you start at a horizontal line, and then you go to a slope. Any slope. Any slope to horizontal. And let me show you right here how speeding up matches this. Here's my horizontal line, and here's my slope. So this is speeding up. Here I have one where I'm starting out with a slope, and then I end up with the horizontal line. That's slowing down. And here I start, and I remember I'm always reading from the left to the right. Horizontal line, slope. So that's speeding up. Speeding up and slowing down, kind of tricky. And that's why I had you guys 3 days making those graphs. So hopefully you're trying to, when you saw the curve, that kind of was making sense with your body. Those of you that are kind of like movement doers, like it's a reinforcement for this whole idea of speeding up and slowing down. And then the last one finally. Which section is the object slowing down? And I wish I wouldn't have erased all that. It's letter E. All right, friends, thanks for sticking with us. I hope this made a little bit more sense as I went through it. We're going to give it to you again to see if you can put into action some of the stuff you learned today. Good luck.